Every human alive today shares the same ancient ancestors. Believe it or not, scientists have discovered that humans all descended from Africa. So here's my question. If we all came from the same place, why don't we all look the same? Why is skin color so different across the world? Was it random? Was it evolution? Was it survival? Or was it something else entirely? I discovered that the answer has nothing to do with culture or race, and everything to do with the sun. And it all starts with one vitamin. So around 200 to 300,000 years ago, early Homo sapiens, that's the species us modern humans derive from, all lived in Africa. And they were dark-skinned, not as a cultural identity, not as a social category, but as a biological necessity, because near the equator, the sun gets pretty brutal. Intense ultraviolet radiation constantly hits the skin, and those UV rays have a target inside our body. That target is called folate, a B vitamin critical for DNA repair, cell division, and healthy pregnancies. Too much UV radiation destroys folate, and when folate drops, well, reproduction fails. So early humans in Africa evolved to have high levels of melanin, the pigment that darkens the skin. Think of melanin as a natural sunscreen. Not only does it darken the skin, but it also absorbs and disperses UV radiation before it can cause damage. Melanin actually comes in two main forms: eumelanin, which produces darker brown and black pigments, and pheomelanin, which produces lighter reddish and yellow tones and is more common in northern latitudes. Because lower UV environments, like Norway and Iceland, reduce the need for darker-skinned people to develop protection, lighter-skinned people became incredibly efficient at producing vitamin D. Conversely, people with higher concentrations of eumelanin tend to have darker skin, darker hair, and darker eyes, and that pigment is extremely effective at absorbing UV radiation. In fact, studies suggest that dark skin can filter out up to 95% of UV radiation, which makes melanin incredibly valuable in regions with intense sunlight. But that same protection can become a disadvantage in places where sunlight is scarce. The same pigment that protects us against UV rays also blocks the radiation needed to produce vitamin D, and the trade-off would become critical as humans move north. In short, in equatorial Africa, dark skin was not cosmetic. It was literally survival. Starting around 60 to 70,000 years ago, early humans started leaving Africa. Small groups began migrating north to follow resources and new opportunities. They moved into the Middle East, Europe, and eventually Asia. But they didn't leave Africa all at once. Instead, it likely happened in waves. Small groups of hunter-gatherers followed animals, rivers, and coastlines into new territories. At the time, the Earth's climate was shifting. Ice ages caused sea levels to drop and deserts to shrink, opening temporary green corridors across regions that are now barren. One of the most important routes was across the Bab el-Mandab Strait, a narrow stretch of water between Africa and the Arabian Peninsula. During periods of low sea level, this crossing may have been only a few miles wide, but as humans moved into completely new landscapes, they encountered something unexpected. When humans moved into Europe and parts of Western Asia, they soon realized they weren't alone. They encountered Neanderthals. Neanderthals had evolved outside of Africa hundreds and thousands of years earlier, adapting to colder Ice Age climates. They had stockier bodies, larger noses for warming cold air, and like humans living in northern regions today, many likely had lighter skin that helped absorb weak sunlight. When modern humans arrived in Eurasia around 50 to 60,000 years ago, the two groups didn't just compete. They interacted, and in some cases they even had children together. Today, most people with European or Asian ancestry still carry about 1 to 2% Neanderthal DNA. That means the story of our human skin and human evolution isn't just about adaptation. It's also about the mixing of different human populations as our species spread across the planet. Each generation moved only a little bit farther than the last, but over thousands of years, those small steps carried our species across the entire planet. And as humans moved into new environments, their bodies began to change with them. The further they traveled from the equator, the weaker the sunlight became. Less UV radiation, less intensity, less danger. But this created a new problem. While sunlight may destroy folate, that B vitamin that melanin evolved to protect, it also helps our body produce vitamin D. and vitamin D is essential for bone health and our immune system. Without enough UV exposure, humans struggle to make enough vitamin D. So in northern climates, dark skin actually became a disadvantage because it blocked too much UV. So over thousands of years, natural selection began favoring lighter skin in those northern regions. Not because lighter skin was better, but because it allowed more UV penetration for better vitamin D production. This didn't happen overnight. It took thousands of years, but slowly, human populations adapted to their new environment. Here's where things get even more interesting. Skin color isn't just dark or light. It exists in a spectrum, and it's controlled by multiple genes, including ones like SLC24A5 and MC1R. They influence melanin production. Scientists estimate that some of the genetic mutations responsible for lighter skin in Europe spread surprisingly quickly, within the last 5 to 10,000 years, which means for most of human history, many ancient Europeans likely had darker skin than people living in those regions today. And evolution is still happening. Human appearance has continued changing far more recently than many people realize. Different populations have evolved lighter skin through slightly different genetic pathways. For example, diet also played a huge role. Some northern populations, particularly Arctic groups like the Inuit, traditionally ate diets extremely rich in vitamin D from foods like fish, seal, and whale. Because they obtained vitamin D through food rather than sunlight, they did not evolve extremely light skin the same way Europeans did. This is one of the clearest examples of how our environment, biology, and culture interact. Different populations faced the same environmental challenge, but solved it in different ways. Some adapted biologically through lighter skin, others adapted culturally through diet. Evolution doesn't follow just one path. It follows whatever path allows humans to survive. Scientists call this convergent evolution, when nature independently arrives at the same answer, but by different routes. The sun asked the same question in two places, and evolution answered twice. Here's something most people don't realize. Skin color is one of the most superficial biological traits humans have. Genetically, humans are incredibly similar. Two random people from different continents are often more genetically alike than two chimpanzees from the same forest. The visible differences we focus on represent a tiny fraction of our DNA. Skin color changed relatively quickly in evolutionary terms because it only required small adjustments in melanin regulation. But beneath that, we are overwhelmingly the same species with a shared recent origin. If you look at a world map of UV radiation levels, populations living closer to the equator tend to have darker skin. Populations further from the equator tend to have lighter skin. It's a global gradient, not political, not social, but geographical. The sun shaped us. The intensity of ultraviolet radiation left its mark on human biology, and that mark became visible on our skin. So why do humans have different skin colors? Because our ancestors moved into new environments, and their bodies adapted to survive them. Too much UV destroys folate. Too little UV starves you from vitamin D. Human skin color is the result of thousands of years of adaptation, a biological compromise between protecting folate and producing vitamin D. It's not a marker of separate origins, it's evidence of a shared ancestry, the same species adapting to different environments, all influenced by the sun. Thank you so much for watching. If you enjoyed this video, then you probably want to subscribe to this channel. I'll be exploring all kinds of human behaviors, like why do we speak different languages, and why do we play certain games, and what's the history of those games? Or why do different cultures believe in different gods? I'll be choosing a different topic each week to explore the world that shaped and influenced us. If you have a question, theory, or mystery you'd like me to explore, please go ahead and leave them in the comments below or post it in our community tab here on YouTube. Until next time.